Okay, so the part 5 of the week 4 um, audio notes. So we will start now, continue with the bug deformation processes, and this operation is going to be the extrusion. In the extrusion process is we just compressing the metal part and force it to flow through a die opening to produce the desired cross-sectional shape. So if you saw any aluminium section, actually was made by this process. To simplify the process for you is similar to the squeezing of the toothpaste out of the toothpaste tube. So the part we're going to generate is going to be a cylindrical shape. In general, the extrusion is used to produce long parts of uniform cross sections. Two basic types we have for the extrusion. We can have the direct extrusion and we can have the indirect extrusion. In the direct extrusion, we are going to have the material to flow in the same direction of the ram, okay? Also sometimes called the forward extrusion. So the starting pellet cross section is going to be usually round. The final cross section of the shape of the extrude is going to be determined by the die opening shape. As the ram is going to be approached, the die opening, okay, as the ram is going to approach the die opening, a small portion of the pellet is going to remain that cannot be forced through the die. So you can see at this corner here, we're going to have some materials cannot simply go through the die opening. And this portion is going to be called the butt. Butt must be separated from the extruded part by cutting it off just beyond the die exit. Now we have, well, I think let's miss that. Yep. So also we can have the hollow and semi-hollow shapes for the section we can make. Simply if I get to add the mandrel to the ram, this will cause a cavity within the extruded part. And that's what you can see here once again. This is the direct extrusion to produce a hollow, hollow or semi-hollow cross sections. You can see that this is the hollow types and this is the semi-hollow cross sections. Again, the direct extrusion where the ram is going to move to the right and the final work part is also going to go through the die by moving to the right. Then the indirect extrusion process, or what we call the backward extrusion and reverse extrusion, you can see that the part is going to be moved to the opposite direction. Okay, so this is the ram. It's going to have the die as part of the ram. We move the ram to the right, the material will be formed to the left. The same thing here, you can see that the ram is going to be pushing the material toward the container, and then the part is going to start moving to the left. It has some limitation, which imposed by first the low rigidity of the hollow ram, and also difficulty in supporting the extruded product as going to be exit the die in the opposite direction. The advantage of the extrusions are first, a variety of the shape possible, especially for the hot extrusion, but the limitation is going to be the part cross section must be uniform throughout the length. The grain structures and the strength enhance in the cold and the warm extrusion processes. Close tolerances are can be possible, especially in the cold extrusion, and in some operations, little or no waste of the materials may happen. For the hot and the cold extrusion, in the hot extrusion, prior heating of the pellets to go above the recrystallization temperature must be done. We said it's going to be something like half of the melting temperature. This will reduce strength and increase the ductility of the metal, permitting for the more size reduction and more complex shapes to done. For the cold extrusion, generally is going to be used to produce discrete parts, shorter parts, and the term impact extrusion is used to indicate the high speed of the cold extrusion. So that was the part number 5. We're going to have calculation question in the tutorial for the exposure process as well.